a dream to fly higher. We launch planes, rockets, and high-altitude balloons to explore space, carry out research, or sometimes just for fun. Hi, I'm Pedrin from SMK Tengku Ampua Rahimah, also have the same ambition to explore space. Therefore, I present to you the high-altitude autonomous glider. As a high school student, it's impossible for me to launch a rocket or any other space vehicle. So therefore, I'll begin with a simple method, which is to use to launch equipment with a helium balloon. I chose to use a glider to help in my survey. So for this, mainly my glider is used to collect atmospheric data and experiment the data on different altitudes. So we have on board is a system to collect data. All these sensors are basically controlled by Arduino Nano. This is the microcontroller. Other than that, by using the parachute, it might be influenced by wind and will be blown away to different locations. With the onboard of Ardupilot, the glider can carry out autonomous mission to fly back to home. So other requirements are such as a data logging system, auto-release system for parachute releasing, and the autopilot triggering.
Alright, so now I'll explain the workflow for the parachute releasing and autopilot triggering system. The onboard barometer will read and send the altitude reading to Arduino. Arduino will then check the altitude reading if it's above 23 km. If it's not, then they will continue reading and checking the altitude's level. Once the altitude is above 23 km, relay will be triggered for 0.5 seconds and the wire will be short circuited to produce sufficient amount of heat to burn the parachute string. Then wait another 10 seconds for the glider to stabilize itself under free fall. PWM value of 1500 will be sent to Ardupilot Microcontroller and Autopilot will be triggered. So this is the Arduino code. In the loop section, we are reading and storing the barometer's altitude reading. Then we'll check if the altitude is above 23 km. If it is, then we'll trigger relay for 0.5 seconds and then wait for 10 seconds. Then we'll constantly send the PWM value of 1500 to trigger autopilot. So on screen now you can see is the mission planner software. You can see the current mode changes to RTL with the current PWM written as 1500. How data logging system work is basically the onboard sensors such as GPS module, barometer, UV sensors and real-time clock module. They will read and send their respective sensors reading to the Arduino. Then the SD card module will save all the sensors reading along the journey. For data logging system, the loop section will check if the GPS is available to receive data, and if everything's doing well, then we'll begin the data logging. So once the data logging function is called, the SD file will create a text file and then it will begin to log census value into it. So this is the result for data logging system. As you can see, the text file shows census reading.
Today we'll be conducting CG and glide capability tests on our glider. So basically we will fly our box wing to a certain altitude high enough and then we'll off our throttle and see how stable and the kite range of this box wing. Using resistant chromium wire, where sufficient heat will be generated to cut the string on the parachute. Alright, so now we will trigger the switch. Along this journey, I have learned a lot from ground controls up to aerial vehicles. Sadly, I'm not able to launch our high altitude autonomous glider yet in Malaysia due to restrictions of UAS restriction on the altitude as well as the flight area and payload restriction for high altitude balloon by the DCA and CAAM in Malaysia. So in the future, we are planning to launch our glider in countries that are less restricted. That's all from me. Thank you and bye-bye.